Hello everyone, my name is Raquel Marcos Saavedra and today I'm going to talk about our paper Multirobot Transport of Deformable Objects using Deformation Modes. Transporting large, heavy or fragile deformable objects is a highly relevant task in several fields, such as industry. We propose a formation controller for transporting deformable objects in 2D space. With this, we control the deformation of the robotic formation, which determines the deformation of the transported object. The goal is to steer a team of mobile robots to a target configuration defined as a combination of desired position, orientation, shape, and scale. Note that the shape of the target configuration is defined with the same shape as the reference one. The control strategy is based on individually controlling its configuration parameter and using a linear combination of the individual controllers. Our novel idea in this paper is that, during the transport, we allow linear and quadratic deformations, which enables preserving the integrity of the object while making the transport system highly flexible. During the manipulation task, two situations can take place. If the task does not require that the object's shape is modified, the formation will be kept in a shape-preserving configuration. But if the formation needs to deform the object, it will be constrained to linear and quadratic deformation modes, allowing stretching, shearing, bending, and twisting while avoiding other unsuitable and unpredictable deformation patterns. We validate our controller using multiple unicycle robots of the Robotarium. We first run simulations where a bent initial configuration is driven to a straight target one. In the case on the left, as we are not controlling the deformation during the transport, the object is deformed in an uncontrolled way. In the case on the right, the deformation is controlled and tends to preserve a quadratic bending-like pattern. In both cases, the team of robots approaches the same shape as the reference one. We also test the proposed controller in a real scenario with obstacles, where a simulated seat is transported along a curved corridor. We apply three different strategies. In the case on the left, we control the position, orientation, and scale, but not the shape. In the middle one, the shape is controlled, but not the deformation, so the robotic formation tends to preserve the shape of the object, but the deformations, which appear inevitably due to the constraints of this particular scenario, are uncontrolled. Only in the case on the right, since we control both shape and deformation, the object deforms in a controlled way, preserving its integrity. For the next steps, we want to further analyze the properties of this controller and to extend it to 3D. Thank you for watching.